For this problem, we are required to determine the value of end moment and wall shear at the peak support, and the value of midspan deflection. Step number 1. Show the wall shear and wall moment as unknown. Para sa peak support sa point A, meron tayong MA or yun yung wall moment, and BA, yun yung wall shear, and same naman sa point B. Step number 2. Draw the possible shape of the elastic curve of the beam. Step number 3. Draw a tangent line at both built-in support of the beam. Unahin ko mag-drawing ng tangent line sa built-in support sa point A. Alam natin na ang value ng slope ng tangent line sa peak support ay 0. Kaya naman ang itsura ng tangent line is horizontal. Kapag nasa point B tayo, yung distance ng elastic curve at tangent line is the deviation of point B relative to a tangent drawn to the elastic curve at point A. At kung mapapansin natin, ang value niyan ay 0. Next is sa point B naman tayo mag-drawing ng tangent line. At kapag nasa point A tayo, yung distance ng elastic curve at tangent line is the deviation of point A relative to a tangent drawn to the elastic curve at point B. At kung mapapansin nyo, ang value niyan ay 0. Step number 4. Construct the moment diagram by parts. Kapag fixed-ended yung ating beam, it's either sa left or sa right support ka magte-take ng axis at doon mo imo-moment yung bawat load ng beam. For this problem, ang i-consider ko na peak support kapag nag-moment diagram by parts ako is yung point A, para hindi ko na i-extend pa yung uniformly distributed load. Kasi, kapag yung point B yung pinili ko na axis, i-extend ko pa hanggang point B yung uniformly distributed load. So magdadagdag at bawas pa ako ng load. Dadami pa yung area sa moment diagram by parts kapag yung point B yung pinili ko na axis. Unahin nating i-drawing yung moment diagram ng shear B. Dahil concentrated load yan na pataas, therefore yung moment diagram natin is pa-triangle na nasa positive side. Ang moment ng shear B sa point A is equal to shear B times the total length which is 4.1. Next is yung MB. Kapag yung point A yung kinonsider natin na peak support and base sa rotation ng MB, yung moment diagram ng MB ay nasa negative side. Dahil moment na mismo yan, ilalagay na lang natin na value niya is negative MB. Yung next na load na gagawa natin na moment diagram is yung applied load na 15 kN. Base din sa rotation ng 15 kN na moment, ang moment diagram niyan ay nasa negative side. At ang value nito sa moment diagram ay negative 15 kN. At yung last load na gagawa natin ng moment diagram is yung uniformly distributed load. Yung curve ng moment diagram from uniformly distributed load is in second degree curve. Solving for the value of moment of uniformly distributed load at point A, that was equal to 15 times length 2.5 times moment arm 2.5 over 2. And that was equal to 46.875 kN. Step number 5. Compute the deviation at built-in support. Yun yung ating deviation of A over B. Ang formula niyan ay equal sa 1 over EI multiplied by the area bounded from point A to point B multiplied by bar XA. And that is equal to 0. Next is the deviation of B over A that was equal to 1 over EI multiplied by the area bounded from point A to point B multiplied by bar XB. And that is also equal to 0. Looking at the formula of our deviation, kailangan natin ng value ng area ng moment diagram bounded from point A to point B. Kailangan din natin ng value ng bar XA, or yun yung distance ng centroid ng moment diagram measured hanggang point A. And last, kailangan din natin ng value ng bar XB, or yun yung distance ng centroid ng moment diagram measured hanggang sa point B. For the triangular load, i-denote natin yung area niyan as area 1, equal yan sa 1/2 ng length 4.1 multiplied by the intensity, or yun yung value ng moment, which is equal to 4.1 shear B. And that was equal to 8.405 shear B. Next is area 2. Yan yung moment diagram ng MB. Equal yan sa 4.1 times negative MB. Therefore, area 2 is equal to negative 4.1 MB. Next is A3. Yan yung moment diagram ng 15 kN na moment. Equal yan sa 3.3 multiplied by negative 15, which is equal to negative 49.5. And next is A4. Yan yung moment diagram ng uniformly distributed load. Ang area niya na equal sa 1/3 ng length, 2.5, times intensity or yung value ng moment, negative 46.875, and A4 is equal to negative 39.06. Unahin natin kunin yung bar XA ng triangle, equal yon sa 1/3 ng total length which is 4.1, and that was equal to 1.37. For the value of bar XB, that was equal to 2/3 ng 4.1, which is equal to 2.73. Para naman sa area 2, yung centroid niyan ay nasa gitna, so yung bar XA and bar XB ay equal lang, which is equal to 4.1 over 2 or 2.05. Para naman sa area 3, yung length ng area niyan ay equal sa 3.3 at yung centroid niyan ay nasa gitna, kaya yung bar XA and bar XB is equal, which is equal to 3.3 over 2 or 1.65. Para naman sa second degree curve, yung length na ito ay equal sa 3/4 ng length niya, which is equal to 2.5. And that distance is equal to 1.875. And this distance is equal sa 1/4 ng 2.5, which is equal to 0.625. Para sa bar XB ng second degree curve, equal yon sa 1.875 plus 1.60, which is equal to 3.475. Dahil meron na tayong value ng area ng bawat moment diagram, meron na din tayong value ng bar XA and bar XB, pwede na nating masolve yung value ng deviation. Mag-start tayo sa value ng deviation of A over B, equal yon sa 1 over EI, multiplied by the area bounded from point A to point B, times bar XA. Mag-start tayo sa triangle, ang area niya ay equal to 8.405, sure B, times bar XA, 1.37. Minus area 2, 4.1 MB. Ang bar XA niyan ay 2.05. Minus area 3, 49.50. Ang bar XA niyan ay 1.65. And last, area 4, negative 39.06. Ang bar XA niyan ay 0.625. The value of deviation of A over B is also equal to 0. Kapag cross-multiply natin yung EI sa kabilang side ng equation, kaya mawawala na yung EI sa equation. By simplifying this equation, 0 is equal to 11.51 sure B minus 8.405 MB minus 106.09. I-denote natin yung equation na to as equation 1. Next is the value of deviation of B over A that was equal to 1 over EI multiplied by the area of moment diagram bounded from point A to point B multiplied by bar XB. Mag-start tayo sa triangle. Ang area niya ay equal to 8.405 sure B multiplied by bar XB, 2.73. Minus area 2, 4.1 MB, at ang bar XB niyan ay 2.05. Minus area 3, 49.50, ang bar XB niyan ay equal to 1.65 plus 0.80, yun yung 2.45. Hindi natin nailagay kanina. Minus area 4, 39.06, multiplied by 3.475. Yung deviation of B over A ay equal din sa 0. At kapag cross-multiply natin yung EI sa kabilang side ng equation, magmumultiply yan sa 0 kaya mawawala na yung EI sa ating equation. By simplifying this equation, this will become 0 equals 22.95 sure B minus 8.405 MB minus 257.01. I-denote natin yung equation na to as equation 2. By using equation 1 and equation 2, pwede natin itong pag-subtractin para mawala yung MB sa equation. 11.51 shear B minus 22.95 shear B is equal to negative 11.44 shear B. Negative 106.09 minus negative 257.01 is equal to positive 150.92. By computation, the value of shear B is equal to 13.19 kilonewton. By using equation 1 or equation 2, i-substitute lang natin yung value ng shear B para makuha yung value ng MB. Gamitin na lang natin yung equation 1. Using equation 1, that is 0 is equal to 11.51, shear B is 13.19 kilonewton minus 8.405 MB minus 106.09. By computing the value of MB, that was equal to 5.44 kilonewton meter. After determining the value of shear B and MB, we can now able to determine the value of MA and shear A. By using the equation of static equilibrium and applying summation of all forces vertical is equal to 0, shear A plus shear B, which is 13.19 kilonewton, minus yung load na 15 kilonewton per meter, times length 2.5, is equal to 0. By computation, the value of shear A is equal to 24.31 kilonewton. Next is by taking the summation of all moment at point A is equal to 0 by taking all counterclockwise rotation as positive. Unahin natin i-moment yung shear B. Ang value ng shear B ay 13.19. Ang moment arm niyan hanggang point A is 4.1 meter. Positive kasi counterclockwise rotation. Minus MB kasi nagro-rotate ng pa-clockwise yung MB. Ang value ng MB ay 5.44 kilonewton meter. Minus yung 15 kilonewton meter na applied load, pa-clockwise kaya negative. Minus yung load na 15 kilonewton per meter, magro-rotate din ito ng pa-clockwise sa point A kaya negative. Ang moment ng uniformly distributed load sa point A ay equal to 15 times length 2.5 multiplied by moment arm 2.5 over 2. Plus MA kasi nagro-rotate ang MA ng pa-counterclockwise, equal to 0. MA lang yung unknown sa equation na to, and by computing the value of MA, that will be 13.24 kilonewton meter. Para sa last na hinahanap, sa problem na to, ay yung value ng deflection sa midspan. I-denote natin na point C, yung midspan. Kapag nag-drawing tayo ng tangent line sa point B, yung distance ng elastic curve at tangent line sa point C ay equal sa deviation of point C relative to a tangent drawn to the elastic curve at point B. At equal din yan sa deflection sa point C. Kapag naman sa point A tayo nag-drawing ng tangent line, yung distance ng elastic curve at tangent line sa point C ay equal naman sa deviation of point C relative to a tangent drawn to the elastic curve at point A. Equal din yon sa deflection at point C. So, dalawa yung available na solution yung meron tayo, using deviation of C over B and deviation of C over A. Kapag yung deviation of C over B, ang gagamitin natin, ang papasok ay yung area ng moment diagram bounded from point C to point B. At kapag ang ginamit naman natin is yung deviation of C over A, ang papasok na area sa moment diagram ay yung area bounded from point A to point C. So, mas madaming area yung papasok kapag ang ginamit natin is yung deviation of C over A. Kaya ang gamitin na lang natin sa solution is yung deviation of C over B. At i-equate natin yung value niyan sa deflection sa point C. The formula for deviation of C over B is equal to 1 over EI multiplied by the area of moment diagram bounded from point B to point C multiplied by bar XC. Katulad ng inexplain ko na sa mga naunang video, yung y1 mag-i-equal lang din yan sa kalahati ng moment sa point A, since yung y1 ay located din sa kalahati ng distance ng beam. So, y1 is equal to 2.05 shear B. Para naman makuha yung value ng y2, gagamitin lang natin yung squared property of parabola. 46.875 is to 2.05 squared is equal to y2 is to 0.45 squared. y2 is equal to 1.519. Solve natin yung mga value ng moment diagram bounded from point B to point C. I-denote natin na area 1, yung area ng moment diagram na pa-triangle bounded from point B to point C. Ang area niya na equal sa 1/2 ng length 2.05 multiplied by y1, which is equal to 2.05 shear B. And the value of area 1 is equal to 2.10 shear B. For area 2, yan yung moment diagram ng MB, equal yon sa negative 2.05 MB. Para naman sa area 3, yan yung moment diagram ng 15 kN na moment, equal yon sa negative 1.25 times 15. Therefore, the value of area 3 is equal to negative 18.75. For the value of area 4, yan yung moment diagram ng 15 kN per meter na uniformly distributed load. Ang area niyan bounded from point B to point C ay equal sa 1/3 ng length 0.45 times y2, which is 1.519. And the value of area 4 is equal to 0.228. Ang kailangan lang natin sa solution na to is yung bar XC, or yung distance ng centroid ng moment diagram measured hanggang sa point C. Para sa area 1, or yung triangle, ang bar XC niya ay equal sa 1/3 ng 2.05. And that was equal to 0.68. Para naman sa area 2, kalahati lang yon ng distance ng rectangle, equal yon sa 2.05 over 2, or 1.025. Para naman sa area 3, yung bar XC ng rectangle ay equal lang din sa kalahati ng 1.25, which is equal to 0.625. Para naman sa second degree curve, yung value ng bar XC ay equal sa 1/4 ng 0.45, which is equal to 0.1125. Meron na tayong value ng area ng moment diagram bounded from point B to point C. Meron na din tayong value ng bar XC sa bawat area ng moment diagram. Pwede na natin makuha yung value ng deviation of C over B. Deviation of C over B is equal to 1 over EI multiplied by the area bounded from point B to point C times bar XC. Mag-start tayo sa area 1. Ang area niya na equal to 2.10 shear B. Ang value ng shear B ay 13.19 kN multiplied by bar XC, which is 0.68. Minus area 2, ang value ng area 2 ay 2.05 MB. Ang value ng MB ay 5.44 kN multiplied by bar XC, 1.025. Minus area 3, 18.75 multiplied by bar XC, 0.625. Minus area 4, 0.228 multiplied by bar XC, 0.1125. Katulad ng inexplain ko kanina, the value of deviation of C over B ay equal din sa deflection at point C, and by computation, the value of deflection at point C is equal to negative 4.35 over EI kilonewton meter cube. And the direction is downward.